Hello, everybody, and welcome to our webinar about achieving compliance with the European Union's General Data Protection Regulation, or abbreviated GDPR. My name is Axel Treuke, and I'm in charge of Grandite, a Canadian supplier of tools and services in the realm of data and process modeling, master data management, and data governance. Mentioning data governance, what you will learn throughout this webinar is not limited to GDPR, but is applicable to privacy laws and data governance requirements in general. The challenges of GDPR are manifold. Here and today, we will look at the example of an organization seeking GDPR compliance while using an ERP application system such as SAP. In case you're wondering if this webinar is for you because you do not employ any ERP system, in any way question whether GDPR is a regulation that affects your organization, I'd like to reassure you, yes, regardless of where you are located, most likely the GDPR applies to your organization. The approach shown here is also useful in context with other regulation, such as PIPEDA or HIPAA, and the approach will help you to analyze any application system employed in your organization. But first things first, for those of you that only have a vague idea, the GDPR is a European law to protect fundamental rights and freedoms of natural persons, and in particular, the right to the protection of personal data. For your reference, you will find the entire GDPR in the language you are most comfortable with on the EU's page shown in the footnote here. So why talking about GDPR now? Because with only a few months left, GDPR requires extensive preparation and affects virtually every organization worldwide. Considering the massive fines of up to 4% of an organization's annual turnover and no further grace period, ignoring the GDPR is not an option. But how can a European law have any impact outside of its jurisdiction? Let me explain. GDPR addresses obligations for organizations established within the EU, as well as rights of individuals being in the EU. More precisely, GDPR sets out obligations on EU organizations to protect the personal data of all individuals worldwide. But on the complementary, protecting the rights for all individuals in the EU automatically sets out obligations on all organizations worldwide to respect these rights. Now, some organizations may conclude, we are not established in the EU and we are not doing any business within the EU, so the GDPR does not affect us. Is that correct? Let's assume the following example case. It's 2018 and a local bank in the US state of Vermont offers, beside other banking services, mortgages to homeowners in the region. One of their customers, let's call him Tim, recently bought a new home, which that bank financed. As it happens in real life, Tim today accepted an attractive professional assignment in Europe for 1 year. Since he will work abroad only for a limited period of time, Tim decided to keep his house in Vermont, accordingly continues to pay his mortgage, has a neighbor to take care of his house during his absence, and looks forward to enjoying his home after his return. The impact on Tim's bank in Vermont? During the time of his assignment in Europe, Tim will be a European resident and therefore be protected by the GDPR. Or, in other words, the GDPR is applicable to Tim's bank in Vermont. Furthermore, GDPR does not only protect individuals that are customers, but all natural persons in any role. May they be employees or may they be contact persons at European suppliers. As long as these individuals are within the European Union, they are under the protection of the GDPR. So unless your business can exclude to ever be in touch with anyone in Europe, the final conclusion is GDPR applies to all organizations worldwide. As a note of caution here, let me point out I am not a lawyer and therefore nothing in this presentation should be construed as legal advice. In this regard, my role only is to help frame questions and suggest solutions for your discussion with your legal counsel. Let's now look at some substantial obligations that organizations have to adhere to with respect to personal data. Naturally, to be compliant with GDPR or to pursue a data governance initiative in general, you will first need to create an inventory of the personal data that are stored and processed by your business and answer questions like the ones shown here, or in short, who does what, when, and where. Let's bring this to life with our example scenario. We will identify personal data in SAP, more precisely in SAP's module PA, Personal Administration, and extract and transfer the physical data model of concerned tables to Silverrun, our flagship tool for data and process modeling. Since a simple reverse engineering of the SAP database is possible, but will leave us with cryptic technical names and thus clueless which are personal data, we will use Sapphire, the industry's only dedicated metadata discovery solution for ERP and CRM systems, to do the extraction. Sapphire has access to SAP's data dictionary and therefore reveals all SAP objects together with their complete description, their business meaning, and their relationships. Why do we transfer this information then to our data and process modeling suite Silverrun? Because it allows us in one central tool to complete the discovery of personal data from all applications of the organization, to add the who, what, when, and where in a standardized way, and to prepare a GDPR-compliant future design of data stores and processes as well. And now I'm delighted to welcome our guest speaker, Nick Porter, who will guide us through the first of these steps. Being the technical director at Sapphire's supplier, Silverwood Technology, Nick definitely is the most eligible person to demonstrate how Sapphire helps to discover personal data in SAP. Nick, please take it away.
Thanks, Axel, for a great summary of the challenges of GDPR. I'm going to show you a typical SAP system that has been reverse engineered into our Sapphire software. What you see on the screen in front of you here is a list of all the tables. As you can see, there are nearly 100,000 tables, which is typical for an SAP system. On that first column, you can see the table names you would find in the database. So they're not very friendly. Obviously, we need the descriptive name to understand what the table is actually for. That's in this second column here. If we look at any of the tables, there are similar cryptic column names. Let's look at this one, the material master. And again, you can see not very friendly column name. And then there is a descriptive name in the third column. Another consideration is there is often a very large number of columns to contend with. And if we're doing some kind of GDPR scoping project, we only really will want a subset of these. On this particular table, you can see there are actually 236 columns, and that's not untypical for an SAP system. So what I want to do now is to try and focus in on particular personal data fields. And in order to do this, I'm going to use a search feature in Sapphire to locate all the fields with a particular string in their description. So I'm going to go to this advanced search, and I'm going to look for any field that contains the string date of birth, a typical piece of personal data that we would need to be concerned about for GDPR. That does a search, and it actually finds 84 tables that contain that particular string. So having found these tables, what I want to do is now record this fact. So I'm going to select them all, and then I'm going to make what we call a subject area. And I'm going to use this option here, and you see it says only marked fields. So it's going to make a group of tables, and it's only going to select the fields which match my search criteria. So it's just letting me check that my search criteria are correct. And then I'm going to give a name to this subject area. And if I want to, I can put in a little comment just to remind me what this subject area was for. And then it's going to create the subject area and populate it with these 84 tables that contain the string date of birth in a field. And if you can see, it shows me how many fields meet those criteria. So you can see it's got this marked fields option, and if I sort that by marked fields, you can see some of them have actually got more than one date of birth field. So this one is an HR master record table, and I can actually filter that down now to just show the marked fields. In this case, you can see there are actually 3 fields with the string date of birth in this particular table. This little comment down here also tells us a little bit more about what this field is for, what the purpose of the field is for. And again, that's coming out of the SAP system. Now I could do similar searches for other personal data fields, and I could create a subject area for each. In fact, I've done that. So you can see we've got things like biometric data, citizenship, driver's license, and we can also merge those. So I can take each set and merge them together, and you'll see that there's this subject area amalgamated, where we've taken the set of each of the fields from each of these different personal data objects, if you like, and merged them. And now when we do that, one of these tables has actually got 47 fields. If we look at that, and again we filter that down to the marked fields, we can see things like name of birth, date of birth, gender, country of birth, names, initials, that kind of personal data information that we'd need to be concerned about. So another way to look at the metadata in this SAP system is using what we call the application hierarchy. And this shows us a set of nodes which are components of the SAP system. So I can look here at the personnel management module, and you can see subcomponents now, and I can expand each of these nodes until I get down to increasing levels of detail. So let's look down here. We've got one called Internet Services, and here is a piece of functionality, what SAP calls a function group. This is a piece of processing in SAP, and then these icons here, these nodes here are actually tables. So it's showing us how the data is used by functionality in the SAP system. So rather than looking at all the tables in the list, we're looking at how the data is actually used by the processing elements within SAP. And what I can do is export this into a file. In fact, I've done that previously, taken the nodes from the personnel management system and exported them into a file and passed it across to Axel so that he can utilize that within Silver Run. I'm not actually going to do that now. We did that previously. And then the other thing we need to do is to export the subject area, the amalgamated subject area that we used. So I'm going to take away this one and add in. I can add as many subject areas as I want. I'm going to take this this amalgamated one, and I can export that also into an XML file. And I've done this actually previously, passed it over to Axel, who's going to show you bringing these two files together within the Silver Run environment.
Thank you, Nick, for this insightful demonstration. Before we move on to the next step, I'd like to mention that Sapphire is not only the go-to product for the discovery of metadata in SAP, but allows to analyze other ERP and CRM systems, such as the ones listed here. Also, the features that come with Sapphire make it not only useful within the journey to GDPR compliance, but in any project that necessitates knowledge of the data structures in ERP systems. To show how the world looks without Sapphire, we use our Silver-Run relational data modeler for a direct reverse engineering of the SAP database. The resulting model will look like this, which is not very helpful, as in the case of SAP, only physical names and data types without any semantics can be retrieved. If we use Silver-Run RDM to load the complete set of metadata that Sapphire is able to extract from SAP and other ERP systems, the result looks like this. Available metadata include the logical name of the tables, the logical names for the columns. We see the logical domain name and also the nullability. And we have the option here, of course, also to see a textual description of each column here for the column industry in the table vendor master. Also, we obtain the relationships between the tables as shown here with their cardinalities. And last but not least, we also obtain the foreign key columns. Or to better get hold of the structure, since SAP tables tend to have 40, 60, 100 columns, here's an overview that only displays the key columns. Let me mention at this point that a Silver-Run can be customized. For example, you can determine which descriptors are displayed, or you can choose your preferred notation. For example, if you prefer the information engineering plus notation, better known as the Crawford notation, here it is. I have used the last few minutes to demonstrate the range of metadata that in general can be transferred from Sapphire to Silveron RDM. To continue now on the path of discovering personal data in SAP for the purpose of GDPR compliance, we will not need to exhaust all of these capabilities. Before we import the subset of SAP tables containing personal data into Silveron, I like to point out that there is no automatism that can decide what personal data are. It requires an excellent discovery tool such as Sapphire that can access the metadata documentation of an application. However, even the best discovery tool can only suggest candidates and therefore needs to be combined with human judgment. Here are a couple of reasons. Metadata are subject to quality issues as production data are. There may be typos spoiling the search, but also synonyms and homonyms will solicit human attention. Last but not least, please bear in mind that being personal data is not an absolute property of a table column. Depending on the context, this characterization can change. For example, 123 Main Street points to a certain lot and house in a city, or in other words, an object that is listed in the city's land register and by itself obviously not personal data. However, if someone lives in that house, 123 Main Street becomes that individual's personal address and as such legally personal data. On the complementary, we may spontaneously determine that age and weight of an individual are very personal data. However, if these data are made available within a set of anonymized records of people, for example, for statistical purpose, age and weight are legally not personal data, as they do not relate to an identified or identifiable individual anymore. If you want to know more about it, please be invited to read my post, GDPR and Personal Data. Context is key and foreign key is context on my blog, Business Modeling Passion, at axeltreuke.blogspot.com. Now let's apply this to the Sapphire extract that Nick prepared in his presentation. Here we have imported Nick's example set into Silveron. So this extract is selected from SAP's module Personal Administration, which for obvious reasons deals with personal data at an elevated degree. And as you have already seen, there's a lot of tables included. To be precise, it's 467 tables and it's roughly 24,000 columns involved. Since these SAP tables are assigned to country-specific modules, we can exclude tables related to modules that administrate employees located outside of the EU. So if we do that, we still have a quite huge model here. To look at this more precisely, it still leaves us with 250 tables and about 12,000 columns. Certainly, this demonstration is not about showing models with a huge number of tables and columns, but to make sure that we have a qualified coverage of all tables that could contain personal data. Now, as I pointed out previously, semantics and context of data are crucial to consider them to be personal data or not. Let's bear in mind that a well-documented physical model, as the one seen here, may reveal the semantics, but not necessarily the complete logical context. To obtain that logical context, the physical model needs to be linked to a logical data model. Here is such a logical model. As mentioned, the physical and the logical model need to be linked to bring context to the physical model. Linking can technically be challenging because the structures of the physical and the logical model may differ significantly, and obviously they do in this case. Therefore, we recommend to link logical and physical model at the column level. Server-on RDM has this rare capability to connect the logical model with the physical model at the column level via the common entry in the business data dictionary. Best practices have taught us to make that link between keys in the logical model and keys in the physical model in a first step, in the same way as we construct a master data management hub. In the logical model, the focus of this example for personal administration is on this table employment here with its alternate key columns, legal entity number and employee number, and their corresponding entries with the same name in the business data dictionary. So let's look at the connection to the business data dictionary. This is what we call in Server-on a common item. So the column, the logical model, legal entity number linked to the common item entry in the business data dictionary of same name. Same applies to employee number, the column in the logical model linked to the data dictionary entry employee number. So let's keep that in mind when we look at, in the next step, how this is represented in the physical model. So let's go back to the physical model and look at the business data dictionary, the common items. So if we look at it from this perspective at the legal entity number, for example, then we can see all the columns in the physical model that are linked to this data dictionary entry. So semantically, the legal entity number from the logical model corresponds to the physical column MEN DT in those many tables of the physical model extracted from SAP. Same applies to the employee number. We look at columns related to that. It's the column PERNR number, which corresponds to the employee number in the logical model. In other words, we have linked the table employment in the logical model to all its correspondences in the physical model. We can link additional columns that are important personal data in the context of the logical model in the same manner. For example, the family name or the person's last name. Is related to this common item of the same name, and which are all the columns that are linked to it. So we see all the columns in the dependent schemas here. So of course our intention here is the physical schema, the physical model that corresponds to the SAP extract. And we see here that quite interestingly, there's a lot of synonyms. So even within SAP, the family name does not always have the same acronym or same physical name for the respective column. Linking columns via the business data dictionary of common items should be repeated until we meet the obligations set by the GDPR to know where all the personal data are. Generally spoken, we can use the same technique to relate the physical model of other application systems of the organization dealing with personal data to the same logical model. This is well supported in Silverrun as it allows to link multiple physical schemas to the same logical model. So what you have seen so far is obviously useful for almost any project that is meant to increase the corporate knowledge and understanding of its application database landscape and to map out the semantic structural data lineage, in particular serving the provisions of the GDPR that require organizations to be able to rectify or even delete all copies of personal data on the data subject's demand. But there's more. Compliance with the EU's GDPR also necessitates answers to these questions. For which business purpose are personal data processed? Or under which jurisdictions are they processed? Or who has access? And most of the organizations that I've spoken with have difficulties to provide the answers fluently. So how can our recommended approach help here? Sapphire provides some essential answers to these questions as well, since it can also export a hierarchical structure of technical processes that show which SAP modules, submodules, and sub-submodules access which of the previously identified tables related to personal administration of European Union employees. Having transferred this hierarchical structure of SAP's components to Silverrun BPM, the business process modeler, we access the previously selected tables in Silverrun's shared repository to use them as data stores. Then we established the links between the SAP processes and those data stores. In Silverrun's business process modeler, the result can be represented as shown here. A hierarchical structure of the modules, submodules, sub-submodules, in this case a vertical tree, showing the name of each module, the semantic name, and the technical number that it has inside SAP. I mentioned that the previously extracted tables are now linked to their respective SAP process. Let's look at this for the process related to the administration of employees in Spain. We have that here. And here is the list of tables, respectively data stores, that are accessed exclusively by this process. On the complementary, if we just go into the list of any stores or tables, we can choose any store here and we get the reference, which is the process that actually uses this table. As mentioned, among others, GDPR requires answers to the question, who processes personal data? Silverrun BPM allows to document the organization-specific answers for each process. In the example here, we assume that there are 3 groups of the Human Resources Department. So group 1 to 3, and they are responsible for employees in North, Central, and South Europe, respectively, as shown here in the 3rd section of each process. Since all these descriptors are documented in the Silverrun repository, we can again have on the complementary the look at the resources themselves and, for example, answer the question, which are all the processes that are in responsibility of the HR group 2. And here we have all those processes listed which are assigned to this group's responsibility. Another important GDPR question is in which country are personal data processed. The answer can be given through a user-defined concept. So here we have a user-defined concept created location, and we see that, for example, the administration of Austrian employees is processed in Germany. Looking at this from the inverse perspective, Silverrun's repository will again give us the answer. So the inverse perspective in the sense of which are all the processes that are performed in Germany. And it will give us the answer, well, it's the administration of the employees in Austria, in Belgium, and in Germany. So at least for this example demo here. This model of technical processes with respectively accessed stores, the processing resources, and their location can be enhanced with additional descriptors to answer any GDPR-related question, and then further elaborated, for example, as a data flow model. The result, although the example here is not related to SAP, could look like this. In this data flow model, processes are represented in green and data stores or tables in yellow. So for each process, we have the name, we have the responsible party to execute this process, and we have answers that are required by the GDPR. For example, what is the purpose of processing, which software is used, what is the protection of the software, like who has access to it, and in which jurisdiction or in which country is this process performed. For the data stores, we have answers, for example, what is the storage type? Could be a mobile device, for example, which is much more risky than a server that is behind closed doors. So here the answer is it's a server. What is their data protection? Well, the operating system is password protected. What is the retention period of the information that is in the data store invoice? And again, in which country are these data stored? To summarize, the Silverrun Business Process Modeler is the tool to document the answers regarding the who, the what, when, where, why, and how of processing personal data as it is stipulated by the GDPR. So the Silverrun tool suite provides you the flexible modeling environment to collect, to store, and to report the meta information that your organization needs to document the status quo with regard to the GDPR. But more importantly, you can refer to, reuse, re-engineer, and enhance these work items while going forward to derive data models, data flow models, and process models for a future GDPR compliant design of your business processes and application systems. As repeatedly mentioned throughout this webinar, the approach shown here and the suggested tools are not single purpose to target GDPR compliance. They serve a variety of initiatives, from projects of application development to programs of enterprise-wide data governance. With that in mind, I'd like to stress that Silverrun does not only work with metadata extracted from Sapphire, but it can also directly reverse engineer virtually any relational database, such as DB2 for ZOS, or Oracle, or SQL Server, and also some non-relational databases. Furthermore, Silverrun can combine the reversed metadata with information from other sources and other formats. To summarize what was raised throughout this webinar, the world has become one global trading place with customers, employees, suppliers, and their representatives being anywhere. That means GDPR applies to virtually any organization worldwide. Procrastination or sidelining GDPR initiatives is not a solution, as other data protection laws will almost inevitably follow. The high bar that GDPR sets will facilitate to comply with additional requirements that other jurisdictions could come up with. At first glance, the GDPR comes with a lot of new obligations, but a closer look shows that this regulation only summarizes long-standing knowledge and best practices for proper handling of data. It therefore also opens the opportunity to lift business processes as well as technical processes to a current level and to be more adequately prepared for future corporate endeavors. I hope we have been able to clarify that achieving GDPR compliance is not just an IT responsibility, but a program that must be initiated and advanced by business departments. In particular, GDPR compliance can only be achieved within the organizational system, which combines culture, people, processes, and software. There's no such thing as an application software that per se is GDPR compliant, even if some vendors like to put that tag on their product. Nor is there a shortcut to GDPR happiness. You will need a central tool set that functions as the extended brain and memory of the organizational system and delivers the documentation as shown throughout this webinar. This is not an academic exercise. It is legally required, as supervisory authorities will ask organizations to prove how they handle the processing of personal data. The produced models of processes, data flows, and data structures are the basis to assess the gaps and risks with regard to GDPR compliance and provide you the runway for the projects and programs you need to set up to close the gaps and mitigate those risks. Silverrun is such a tool that enables you to produce GDPR-compliant documentation. It functions as the extended brain and memory of the organizational system in and outside of this GDPR context and helps you to model future processes and application along the lines of international, national, and industry-specific regulations while embedding corporate strategies. Depending on your application environment, you will need additional tools such as Sapphire to discover personal data. Having said this, your organization will encounter many challenges with GDPR, but also with other organizational endeavors. We do not only have the tools to move your organization towards success, but also the recipes and experience for a customized compliance program. Our services are at your disposition. With that, I want to close this webinar. On behalf of our guest speaker, Nick Porter from Silver Technology, and myself, thank you for your time. We hope you got some inspiration how to tackle the challenges that lie ahead. We welcome your questions and comments through one of the channels mentioned here. Please refer to this webinar and we will follow up shortly. Thanks again and hope to talk to you soon.